the right-hand side of our graph. In order to do this, we need to recall that probabilities, whether you're flipping coin or you are rolling a die, probabilities always add up to 1. Half plus half equals 1. All these probabilities on the inside equal 1 also. So if I'm given, for instance, a z-score that produces a probability of 0.70, what would be left to be shaded in here? Well, you would take 1 and subtract that 0.70, meaning that to the right of the z-score, 30% is now shaded. Likewise, if I told you that 80% of the curve was to the left of the z-score, what percent then would be to the right? Using the notion of probabilities add up to 1, you would simply subtract 80% from 1 and find that that might be 20%. Picture not drawn to scale. So let's consider some more examples. If the z-score is 0.02, you would find the probability at 0.02, 0.5080. But we're looking at areas to the right, so we'll have to subtract 1 minus 0.5080 to get our correct probability. And we'll find that the probability is truly 0.492. I caution you once again to think about what that looks like. A z-score of 0.02 would be very close to the mean. Just a little over half would be to the left, which means just a little under half, 0.492, 49%, would be to the right. In our second example, we need to switch charts and work with a negative chart. Everybody read that one just fine? I'm old. Let's make it big. Negative 1.93. Negative 1.93. I had to switch charts to grab the negative, but I'm still looking at areas to the right. So the probability that I'm going to look for will actually be 1 minus what I have circled, 0.0268. The probability of getting a z-score of negative 1.93 or less, or I could ask, what is the probability of getting a z-score that is larger, since we're talking about to the right, negative 1.93? Probability is pretty high, 97%, because we're looking at negative 1.93 being down here, but we're talking about not the left, but to the right, most of the curve. So it should make, when we're looking for area between two z-scores. This z-score will give us area all the way to the lower sigma limits. The other z-score will give us a cutoff there and an area represented by the cutout box. Reason for that is I don't want that part. I don't want this, and I don't want this. The second x is represented by this cutout area. So if I ask you to find the area between 1.16, 1.16 is 1.16 standard deviations above the mean, and 0.31 is 0.31 standard deviations above the mean. But I'm not looking for either area. I'm looking for those that are between. We don't subtract areas, we subtract probabilities, which means we need a probability from the z-score of 1.16. 1.16 has an area of 0.8770. The other z-score, in red, is going to be subtracted. Its probability of 0.31, its z-score of 0.31 has a probability of 0.6217. So I get my rusty trusty calculator out. 0.8770, get rid of everything that would have been behind the red. We're going to get rid of it by subtracting. 0.6217 is the portion I'm getting rid of. For an area that's shaded of 0.2553. That's the probability of getting a z-score between the two that were given. If one z-score is negative 2.76 and the other z-score is positive 0.31, I have to look at two different charts, but I'm still looking for probability. The probability of the first comes from the negative z-score chart. Negative 2.76 gives a probability of 0.0029. The probability of a z-score that is 0.31, go to the positive z-score chart. 0.31 is 0.6217. Since I'm looking for the area shaded in blue, I'm going to have to subtract that which would have been given by the lower z-score. I have to get rid of that. I get rid of it by subtracting. You can't have a negative probability, so you have to take the big number minus the small number. My calculator tells me that the shaded blue area, that percentage of the curve, would have been about 6188. Almost 62% of the curve is shaded. Last example, let's look at two that are both negative. Negative 3.01 would be considered very unusual because it's outside the sigma limit of 3. The second one, also negative, negative 1.83. They both need probabilities. They both have probabilities. They both come from the negative probability chart. Negative 3.01 would give us a probability of 0.0013. The probability of the second, still on the negative chart, negative 1.83, leads us to a probability of 0.0336. I'm looking for this shaded portion of the curve right here. How much is shaded? We subtract the probabilities. Big minus small. Can even subtract this one in my head. 0.0323. About 3% of the curve. So the picture is a little deceptive. When I grow up, I will learn how to draw. For now, let's work on statistics. For instance, if I ask what is the z-score with the area of 0.7357, find 0.7357 or the closest thing you can find and trace it back. The z-score will be 0.63. And that's what you would put for the answer. The z-score is 0.63. 0.5120. Well, there it is. So we trace it back. It is a z-score of 0.03. So that's what we would put for our answer. Z equals 0.03. How about 0.7970? How about 0.7970? Well, that one's getting close. That one's very close, and now we got too big. 0.7967 is as close as I can get. Sometimes that happens. The exact probability is not there. So you have to choose the closest one. In this case, the z-score would be 0.83. This leads me to another point. You have something like 0.5060. It's dead even between these two pieces. If the probability is between the two pieces, so is the z-score, meaning we'll take the average of the two that it would have been. 0.01 plus 0.02 and divide them by 2. So our correct z-score would have been 0.15. Not actually on our chart, but the correct answer nonetheless.